Okay, now let's try this one here. Okay, now let's try this one here. Sine of 19 pi over 12. You'll note that we need to break this up into two different values that we can find the value for. Two different values that we can find sine of. We don't want to find sine of 19 pi over 12. We just don't have that. However, we do have things like that are pi over 3 or pi over 4s, stuff like that. So that's what we're going to want to try to calculate it to. So if I have sine of 19 pi over 12, we're going to probably break that down to 4 pi over 3 and pi over 4. Okay. So then what does this equal? This equals, sine, since it's sine, cosine, sine. I'm going to put same plus. So then just go 4 pi over 3, pi over 4, 4 pi over 3, pi over 4. Okay. We know that cosine of pi over 4 is negative square root of 2 over 2, negative square root of 2 over 2. And then my terminal point, according to 4 pi over 3, is the point negative 1/2 square root of 3 over 2. Okay, so I'm going to have negative square root of 3 over 2 here and negative 1/2 there. So I put plus times, and I get here negative square root of 6 over 4 minus square root of 2 over 4, which is negative square root of 6 minus square root of 2 over 4. Okay, we have a couple identities we want to prove. Here's the first one. I'm going to start with the left-hand side. I'm going to use my cosine of a sum formula. So I'll have cosine x, cosine pi over 6 minus sine x, sine pi over 6. And then we're going to have plus sine x, and again it was plus, this was minus because it's the cosine, sine x, cosine pi over 3, and then minus cosine x, sine of pi over 3. So cosine pi over 6 is square root of 3 over 2, so I'll have square root of 3 over 2 times cosine x minus sine of pi over 6 is 1/2, so I'll have minus 1/2 sine x plus cosine pi over 3 is equal to 1/2, so I'll have 1/2 sine x, and then here I'll have minus sine of pi over 3 square root of 3 over 2 cosine x, cancel, equals 0. Okay? Alright, now we're going to use our tangent one. So let's start here. We're going to start with the left-hand side. So if I start with the left-hand side, okay, it's equal to tangent pi over 4 plus x, using my tangent formula, which says if I have this, that's equal to tangent pi over 4 plus tangent x divided by, I have 1 minus tangent pi over 4 times tangent x. Okay, so far so good. Tangent of pi over 4, of course, is 1. Okay, so this will be 1 plus tangent x over 1 minus tangent x, which equals the right-hand side. Oops, I forgot to put right-hand side in this one. Okay, good. Okay, one of our goals is going to be able to have something that's a sum of a sine and a cosine, and be able to write it more simply. And we're gonna look at this. Looks real complex. We'll get to this in just a second. But if we look at it using this kind of triangle that I built here, it'll all make sense. Okay, so let's just kind of go through it. So suppose we were given we have a sine x plus b cosine x, and we want to work with that and make it a little bit simpler. So we don't just have a sine and a cosine. We just want one. We just want, like, say, sine of x. Well, then what you can do is you can note a couple things. If I have this triangle, and this is the point AB, that forces that to be A, and that to be B. Now, the first thing that I'm going to want to do is I'm going to do a little algebra trick and call this the same thing as a squared plus b squared times a sine x over the square root of a squared plus b squared plus square root of a squared plus b squared times b cosine x over a squared plus b squared. Okay? So that's just an algebra trick. These two things cancel out to be 1. Those two things cancel out to be 1 as well. So it's the same. This is exactly equivalent to that guy right there. Okay, so once I have that, I want you to come over here. And I want you to note this right here. I want you to note that if I look at, say, cosine of this angle, this is some angle phi, okay? If I look at cosine of this, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So cosine of phi is A over that guy, square root of A squared plus B squared. So this right here is really cosine of phi. So this is going to equal, if I factor out an A squared plus B squared from both terms, right? Take this out from both terms. This is right here, that's cosine of phi times sine x plus, now check this out, I need another color. This right here, and you probably can't see that on the computer, but that's okay. You have another red to do. This guy right here, that's sine opposite over hypotenuse of this angle phi. Sine of phi, okay, and then I have cosine x. Okay, so I have cosine phi times sine x plus sine of phi times cosine x. Now, isn't that the same thing as cosine or sine of phi plus x or x plus phi? Because we have sine, cosine, cosine, sine. So this is equal to, using our sine of the sum, a squared plus b squared, this is going to be sine of x plus phi. Okay, right there. Now, if I note that, again, that I have these two guys, this is red, and this is, oops, that should have not been red right here, excuse me. That should have been in black. That guy is that guy. Okay, and then if I just say this is some number k, then I have sine of x plus phi times k is equal to this sine, a sine x plus b cosine x. I was able to get it down to here. And that's just what this says. If a and b are real, and I have a sine x plus b cosine x, well, I can make that k times sine of x plus phi, where we define cosine of phi to be this quotient, sine of phi to be this quotient, and k is that number. So that's exactly what we did here. Let's take a look at examples of using this idea here. Suppose I have 3 sine x plus 4 cosine x, and I want to write that in the form of k sine of x plus 3. Okay, good. So we know that k equals the square root of a squared plus b squared. So in this case, my a value is 3, so I'll have 9 plus 16 b values, so I get the square root of 25, which is 5. So I know my k value is equal to 5. So then I want the angle phi such that sine of phi equals 3 over 5, or excuse me, 4 over 5, sorry, we'll have 4 over 5. Because again, according to this, sine of phi equals b over that guy. And cosine of phi equals a is this guy, over 5. Now if you use your calculator on this, again you can just use the sine inverse or cosine inverse calculator. I think phi becomes approximately 53.1 degrees. So then we have everything that we need to put it in this form. Okay, we know what k is 5. So this will equal 5 times sine x plus 53.1 degrees. Okay? Let's try this one. Okay? So the first thing we want to do is we want to find k. K is the square root of a squared plus b squared. So it's the square root of the square of negative root 3 will be 3, right? Plus here I have 1 squared is 1. This equals 2. Square root of 4 is 2. So I know my k value is 2. So then I have cosine of phi is a. A is negative square root of 3 over my k value 2. And sine of phi is my b value 1 over this guy 2. So what angle phi gives us the property that our terminal point is negative 3 root 2 over comma 1/2? Well, that's at 5 pi over 6. So then this will equal, this guy right here will equal 2, because I have my k value, sine of x minus, or x plus 5 pi over 6.